live. Does anybody want to say the prayer?
I'd say the prayer.
I will.
I don't know who said it. I said they would first.
Okay, well, I'm willing.
Okay.
Yeah, you can go ahead.
Okay, thanks. Dear Father in heaven, we're grateful that we can gather together for our class, and we pray that thou wilt bless us as we try to learn and grow together. Please help us to do a good job, and please bless Suzette while she's not with us. In the name of Jesus Christ, amen.
Amen.
Okay, so we got we go through part 2. Or does anybody have any questions on part 2 of the individual preparation?
No, I just need to work on the way I plug things into my calculator because it's not, my Z-score is not always coming out the way it's supposed to.
Yeah, sometimes it was confusing.
Yeah, it all made sense in the end, I think.
I think so too. What about you,
Kenton, I can't see your video.
Okay, here's that. Sorry.
It's okay. I just want to make sure that, okay, I can hear you at least. That's good.
Yeah. Sorry, I had it off.
We don't have to have
Have you
video.
guys taken the exam yet?
Sorry, what?
Have you guys taken the exam yet?
Yes.
It's not. I thought some of it was easy, some of it was harder for me.
Okay. Cool.
A lot of the questions were the same from the like sample thing or this week, but some of them were a little bit different. So I was just like,
Okay.
Well, we can't tell them
also-
too much, though, you know.
Yeah.
I need to start writing down my formulas too, because I'd be like, what did I use for this again? And I never save my spreadsheets for some reason. So that's what happens when you let Excel do it.
Yeah. Do we need to go over part 2, or should we go on to the quiz?
I'm good to go on to the quiz. What about you, Kenton?
The quiz.
Okay.
Sweet, let's do it.
Hopefully there's not a lot of questions.
Oh, wow, yeah.
Yeah, we got to get Kenton out of here in time to take the test. Kenton, you know the test ends tonight, right?
Yeah, I've already taken the test.
Oh, did you? Oh,
I'm
okay.
just wondering how you guys did.
I thought you said you hadn't
So.
taken the test. Oh.
No, I've taken it. I do
cool.
so well, but that's okay.
Well, we
Okay.
can always do better next time.
Yeah.
Let's get this. Okay, we answered 1 and 12, which are both true, hopefully. Question 3, which hypothesis involves equality?
I'm not quite there yet.
The
Sorry, my laptop is slow. Okay, go ahead.
Okay, so number 3 is which hypothesis involves equality with the equal sign, and I put the null hypothesis.
I agree.
Yeah, that's right.
Sweet. So
Me
the
too.
p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. P-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. That is redundant. The p-value, which hypothesis do you assume to be true?
The null.
The null.
And I agree there's quite a bit of redundancy sometimes in the homework and quizzes and things.
That
But
was off.
I don't know. It's kind
Okay.
of
So,
to remember better, I guess.
yeah, I guess so. Suppose the null hypothesis H0 U thingy, I don't remember what that means, equals 10.
I think it's the mean.
Mean equals 10. So which of the following represents the alternative hypothesis for a two-tailed test?
Okay, so the null hypothesis is that the correct answer is 10. So the alternative hypothesis would be for a two-tailed test
Yeah.
would be that the answer does not equal 10.
So that'd be C, right?
Yeah. I think that greater than or less than would each be, they only really have one side to them.
Yeah.
So,
Cool.
Okay, so the next question, which of the following represents the alternative hypothesis for a left-tailed test?
I believe it's the smaller than.
Yes, I think so too.
I'm looking here in my notes though. Yeah. Smaller than is left-tailed.
Yep, that's it.
So A.
Yeah.
Okay.
Which of the following would be right-tailed?
B?
That would be greater than.
B.
Mm-hmm.
Okay. So number 8, remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this information to answer the next two questions. Which relationship would result in failing to reject the null hypothesis? Let's see here.
Yeah, let me look at my notes. Oh, if no. P-value is low, reject the null.
Yeah.
So I guess if the p-value is lower than A, or the
Yes, I
p-value
agree.
is lower than,
No, I think that's correct.
p-value is the area, right? Sort of. It's the probability. It's lower than A. Small, reject the null. It has to be. Oh, this says if the p-value is very small, z-score is very large, reject the null. So maybe it's smaller
So-
than the z-score.
If it's small, we reject the null hypothesis. So I think that would be
Failing to reject. I'm sorry.
9 would be the p-value is less than alpha, but number 8 would be
But 8 would be
Relation-
greater than alpha. Can't quite.
Yes.
What was the answer to number 8?
I'm saying number 8 is p-value is greater than alpha.
Okay, I agree.
Okay.
P-value is less than alpha.
On number 9?
Yeah. Okay. Company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions. Which of the following would be the appropriate alternative hypothesis? HA.
The average
So
claim is greater than?
they think that it's greater than, so that would be the average claim amount is greater than $1,500. On mine, that is
I
C.
agree.
Which of the following would be the appropriate null hypothesis? That would be the average claim amount is equal to $1,500. On mine, that is A.
Right.
Okay, what was
Okay.
10?
Number
10.
10,
Is that
Yeah.
it's greater than 1,500 because they think that it might be greater than 1,500. So the alternative hypothesis is the average claim amount is greater.
And then 11 was equal to 1,500?
uh-huh.
Thanks.
Okay. So the insurance company randomly selects n equals 40 claims and calculates a sample mean of 1,650. Use this information to answer the next 3 questions. The insurance company assumes that the distribution of the sample mean is normal. Is this a good assumption?
Maybe it's more
I
than
think-
30.
I think it's a good assumption.
Oh, and that's
Because
true. We don't know if the population is normal. So I would say
Yeah.
A.
It's a good assumption since the sample size is large. Okay, number 13. What theorem or law justifies your answer? Well,
Law of large numbers?
Central
The law of
limit,
large
I
numbers.
believe.
yeah, that's right. And that makes our answer to number 12. Following is the test statistic as defined in this lesson.
The test statistic.
Yes. Okay. So
Z, I believe. Because we
yes,
use
that is,
the score formula.
yeah, that's correct. It's Z. Okay. Are we all caught up? Number 14 is Z. On, we have
Sorry.
the historical.
Z as in zebra?
Yes.
Okay, cool. Yeah, I'm all caught up.
Okay. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. Suspects the average has decreased. She sets up a hypothesis test with these hypotheses. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes, what is that? That's the mean, right?
Yes,
Sample mean.
that's correct.
$144. Use this information to answer the next 4 questions.
So like the z-score, right?
Correct.
Mhm.
Okay, let's see here.
Use the sample standard deviation formula, right?
I think so.
Because it's a sample of 36 receipts. Oh, it's 36 minus 1, isn't it? Okay, what are you guys getting?
I have not figured it out yet.
Yeah, I'm still trying to calculate it.
Okay.
Um,
Go get your sister. Sorry.
You're fine.
Big sister's babysitting.
Fun.
Go get your sister Mariah right now. You cannot talk to me during my meeting. Okay, do you guys have an answer yet?
Not yet. Sorry.
not yet. So I think what you do is like the minus the mean divided by deviation
Mm-hmm.
divided by square root, or is it just the standard deviation?
Square root of 36 minus 1, I believe.
Okay.
I don't know if I'm right. I think I might be wrong. I got 0.15.
Wow, okay. I've done it 3 times and I've got 3 different answers. And none of them was that.
So what'd you get, Tyler? Or
Give me 1 second to figure this out. I got 0.15, but I know it's wrong.
I think it might be negative 0.025.
I am almost done. I will tell you if I agree.
Okay.
So what did you get?
I got negative 0.025. What did you get?
I got negative 0.09. I mean, negative 0.9.
Okay, well, I also got negative 0.9. When I calculated
Okay.
everything separately, like I did 144 minus 150,
You got negative 6.
and then I did the square root of 35.
Oh, square root of 35?
Yeah, it's 36 minus 1.
Okay, so that's where I went wrong.
Oh, okay.
Okay, but that's probably why you're just a little bit off from me.
Yes, let me put in the 30 square root of 35.
So it should be 5.916.
Yes.
So 40 divided by 5.916
is 6.76123404.
right? Or, yeah, I got close to that. And then,
And then
6 divided by that.
negative 6 divided by that gives me negative 0.887.
That's what I got.
Sweet.
So I need to stop trying to do it all in one shot, I guess.
Well, I know I learned how to do this with just an Excel function, but I don't remember how, and I am not going to take the time to figure it out right now.
Okay. Okay, so the way to remember, if you're dealing with samples, then you need to do, that make sense?
What's that?
With samples, then you need to do the sample standard deviation. The divided by the square root of n minus 1.
Oh.
If it's
Okay.
If it's the population, you just divide it by the actual standard deviation.
Okay.
But like it says, if it gives you a sample size, then you need to do the sample standard deviation.
Okay.
Okay, so number 16, what is the p-value associated with the z-score from the previous question?
Okay, so the z-score was negative 0.887.
Mm-hmm.
So we need to get out the applet. So the question was, she thinks the average has decreased. So she wants to know if it's less than 150.
Tailed.
Yeah. So what is the p-value associated with the z-score from the previous question? I'm thinking 0.188.
What I got.
Because if you plug in 0.887 as the z-score and then highlight the left side only, it says 0.1875. Do you see that, Kelton?
That's what I.
Yeah.
Okay. So now, do we reject the null hypothesis or fail to reject? So is the p-value is alpha, and fail to reject the null hypothesis.
Say it's lower than the alpha.
It's greater than the alpha.
I'm sorry, I can't hear you.
It's greater than the alpha. Alpha is 0.05,
Okay.
and we're at 8. So it's greater than, and from what we said before, if the p-value is greater than alpha, we fail to reject the null hypothesis.
Okay. Yeah, what's that ditty again? If p is small, reject the null. Something like that.
Low, reject the null.
Okay.
Not lower than the alpha.
So we fail to reject.
So what is your conclusion for this problem?
I want to say we have insufficient evidence. Mean is less than 150
Yes.
because we're gathering evidence against the null hypothesis.
Yeah, that makes sense.
I agree. So we have insufficient evidence. Population mean is 50. Okay, so that's C on mine.
Mine too.
Awesome. Team. Of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Hypothesis is true.
Okay.
So that is type 1 error?
I've got it here somewhere.
So if the null hypothesis is true and we reject it, yeah, I think that's a type 1 error.
Right. Rejecting a true null is a type 1.
Sweet.
Okay.
Okay, number 20. A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true?
Okay, I think this was one of our questions. Okay, so if we want to decrease the probability of making a type 2 error, we would increase the level of significance. So if we
What you had said just before.
Yeah, it's part 2, 9D. So
So we increase the level of significance. So
then we'll decrease the probability of making a type 2 error. But he's
okay, so
decreasing it. So we're decreasing the probability of making a type 2.
okay, let's see.
Well, that's not one of the options, is it? Ugh. Okay. So if we decrease it, then we decrease the probability of making a type 1, right? Which means we increase the probability of making a type 2.
Okay, so we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is 0.05. So when the null hypothesis is true, there's a 1 in 20 chance that it would be rejected at the 0.05 level of significance. Cases for alpha include 0.1 and 0.01.
Yes, because there's sometimes when you need to change it. So if you decrease the chance of getting a type 1 error, you're going to increase the chance of having a type 2 error.
So that is B. The probability of a type 2 error will increase.
I agree.
Yeah.
Okay. Number 21. Alpha equals 0.05. Compute the probability of committing a type 1 error. Round to 2 decimal places.
I believe it's 1 out of 20, right?
It is 1 out of 20. So we have, what is that in a decimal form?
0.05. So I think what they're, oh, it says decimal places though. So 0.05. In the homework,
Yeah,
part 2, number 9C, it says if the analysis was done at a 0.01 level, the probability of committing a type 1 error was 1%.
okay.
But they're asking for a decimal.
Let's see here.
So it's 5% or 0.05.
Yeah, I think it's 0.05, which is a trick question if you ask me.
Right.
Okay, do we want to go through it one more again just to make sure? Okay, so let's start with number 3. The null hypothesis. Number 4, I have null hypothesis. Number 5, I have C, alternative hypothesis, mean does not equal 10. Number 6, A, alternative hypothesis, mean is greater than 10.
Wait, on question 6?
And then that, number 6 is A.
Okay. I have the alternative hypothesis mean is less than 10.
That's what I have too, but
Yeah.
I
Okay,
said it wrong.
that's okay.
Number 7 is less than 10. No, greater than 10. I'm sorry, I'm getting them mixed up.
It's okay. I just have to remember
Okay.
left to right, just like you're reading a book, right?
Okay, so number 8 is A, p-value is greater than alpha.
Wait, did we do
Number
number
9.
7? I think you're,
Yeah, number 7.
sorry, I think you're just cutting out a
Is-
bit, so I'm missing some stuff.
Okay. Number 7 is greater than 10.
Okay,
Number 8 is greater than alpha.
okay,
Number 9 is less than alpha. Number 10, the average claim amount is greater than 1,500. Number 11, the average claim amount is equal to 1,500. Number 12, it is a good assumption since the sample size is large. Number 13, central limit theorem. Z as in zebra. Number 15, negative 0.887. Number 16, 0.188. 17, fail to reject the null hypothesis. Number 18, we have insufficient evidence that the true population mean is less than 150. Number 19, type 1. Number 20, the probability of a type 2 error will increase. And number 21, 0.05.
okay.
Okay, let's submit. Yes, submit it. Uh-oh, we got 2 of them wrong.
Uh-oh, which ones?
Number 16, what is the p-value associated with the z-score from the previous question?
We got the wrong z-score.
Uh,
I wish they
And
would
what
give
is
us
the-
the right answer because I'm having such a hard time finding that.
I know. Okay, so let's see here.
I'm just gonna ask the professor to help me clarify my keystrokes on that calculator.
okay.
Quite sure where to put the parentheses, you know?
It's so confusing sometimes.
But we still did pretty good.
Yeah, that is good.
Yeah.
Okay, well, let's try and figure out the z-scores. I'll probably have to do some more research on how I did it last time.
Right.
And we had all the other answers right, so I think it'd be okay if we all went back on our own and just put in those z-scores and did it again. How do you guys feel
Awesome.
about that?
Okay.
Sounds good.
Awesome. Well, thanks for coming, guys. Sorry, I emailed the link to Suzette only because I guess I pressed reply just to her and not reply all
Oh, that's okay.
to the last email she sent. So she's probably like, "Oh yeah, I'm not going to be there," and you guys are like, "Okay, but we don't know." So
You did
awesome.
great.
Well, thanks. Well,
Thank you.
I'll talk to you guys next week.
Okay.